the object is at infinite distance. Okay, when the object is at infinite distance. Corresponding ray diagram to understand the image will be something like this. This is the convex lens. Okay, this is the principal axis passing through the optical center. What is this point is known as? What does this O means? O is called optical center. Write down. O is known as optical center. Okay. O is known as optical center. So when object will be located at infinite distance from the convex lens, where can we see the image? So whenever object will be at infinite distance, it is very difficult to draw the object. It is very difficult to draw the object as a visible one. Okay, anything which is assumed to be at a far distance, that means infinite distance, normally that position is considered as not visible, right? So the object is at infinite distance means object is, suppose if object is, if I consider, if object is object is to the left of the lens, to the left of the lens, then being it is at infinite distance, being it is at infinite distance, it is at infinite distance, hence object is not visible. Okay, object is not, hence object is not visible. As object is considered to be at infinite distance from the convex lens, so basically we cannot show the object in diagram, because the logic is what it is located at far away from the lens. So that's why with respect to position of the lens, we cannot draw the object as a visible item, right? So that's why we will consider the light ray, we'll consider the light rays from infinite distance object will be coming like this. Light is coming parallel to each other, and that is parallel to principal axis. Are you getting me? The light will be considered as a incident ray parallel to principal axis. Okay, so that means this idea suggests us parallel incident rays, parallel incident rays from object. Okay, parallel incident rays from object which is at infinite distance is coming to the lens like this. Now these two light rays, see, basically I told you, and in the very first class I show with the diagram that basically in lens there are two successive refraction, isn't it or not? Do you remember with the diagram I explained that two surfaces S1 and S2, light once passes through S1 going air to glass, bends first refraction takes place through the surface S1 as it enters air to glass, and then again while coming out from the glass to air it gets refracted again. What I was trying to say that why I have specifically written this statement, because in most of the cases you have seen either it is a discussion relating to reflection or refraction. Okay, in all the diagrams whatever we have done relating to mirror cases, relating to refraction cases, everywhere I have shown an uh, an object position in mostly all the diagrams. Yes or no? In mostly all the diagrams I have shown object positions. Either it is a point object or by drawing a vertical line I have tried to relate a dimensional object, either the cases relating to uh, concave mirror, convex mirror, or even plane mirror. Do you remember any diagram, or you just turn back the pages wherever we have done anything, any image, any picture, any drawing related to image formations, whatever we have discussed? Please check your copy. All of you check your copy. Can you see any diagram, whatever we have done till now, relating to reflection or refraction? Have I shown the object position either by just marking a point on the principal axis considering a point object, or somewhere I have drawn object like this? In all those pictures, in all those diagrams, wherever I have shown the object either by showing a dot or a vertical arrow based line like this, that means in all those cases I wanted to explain the position of the object is visible from the mirror or from the lens, wherever object will be said to be at any finite distance, right? Any measurable distance, either it is in case of reflection or it is in case of refraction. Are you getting me? We can always show the object with a symbol of dot or with a vertical line, right, indicating the object is visible to us with respect to the mirror or lens, either to the left of it or to the right of it. Is it clear? But whenever we use the term like object is at infinite distance, that means the object is far away from the mirror or lens, right? So that you can't measure that separation. So if you can't measure the separation, that means the conceptual logic suggests that the object is so far from the reflecting or refracting surface such that it is not visible from there. Are you getting me? That's why in all those diagram, in every book you will see that whenever it is a case relating to object at infinity, explanation of those cases with the diagram, object won't be shown with any sort of marking either by dot or by showing a line. That means object is far away from the lens or mirror, means it is not visible to us, right? That's what I mean it with this sentence, that if I take object is at infinite distance from the lens to the left of it, so that's why object being infinite distance, it can't be seen from this one, it is not visible. So that's why incident ray from the object will be always considered to be coming parallel to each other. Is that clear? Whenever object will be referred to be at infinity, that means we are bound to consider incident rays being parallel to each other. Okay, so that's why I have taken parallel beam of light rays as if it is coming from the infinity. And importantly, see, as I said that earlier, in actual mechanism, I said that I said that that any light ray entering air to glass, lens is a glass medium, it gets refract one, it bends in its path, right, first time, and then again while going from glass to air, it bends second time. Did I say like this? Tell me yes or no. Did I explain the fact of, because I made it clear in the very first class while explaining about the lens, I said that lens is a two refraction taken consecutively. Refraction, lens is a case of double refraction, isn't it? Lens is basically a case of double refraction one after another. The first one is from the outside medium to the medium of lens, and second one is from the medium of lens to the outside. Okay. So ultimately we do consider this is the incident ray, this is the incident ray, and this is the final refracted ray. Are you getting me or not? Are you all getting me? We mainly discuss the incident ray, the portion of the light ray which appears before entering into the lens, and the final refracted ray which is appearing after passing through the lens, right? So that's why we ignoring this double refraction, we can just to use these two light rays, we can sometimes do it like this. We draw a line through optical center, we ignore this part and we consider it something like this. Are you getting me or not? Are you getting me or not? We consider it like this. That means we consider the bending after the line which is passing through the optical center. That's why here also I have done the same thing. Here also I have done the same thing. I have first taken parallel incident ray and I didn't bend it once it is passing through the first surface. I have continued that drawing up till the dotted line which is passing through the optical center, and after that I will consider the bending of it as the refracted ray, and these two refracted ray will pass through one particular point on the principal axis which is called the focus of the lens.